Welcome everybody. Today I want to talk about microphones and microphones only. And as you can see, I'm not alone on this channel today. I've come all the way to Vienna, to Austrian Audio, to meet some real microphone experts. And they're going to answer all my questions and all the questions that you have sent me. So this is going to be a really interesting and nerdy video. Questions like, how do you voice a microphone? Why do ribbon microphones sound darker than condenser microphones? How do you create the polar pattern of a microphone? And do mic pre's even matter? I'm really excited, and I'm here with Christoph, the senior acoustic engineer at Austrian Audio. Hello. Welcome.
Nice to meet you.
But before we get started, let me show you this. This is a wonderful OD505 active dynamic,
correct,
handheld microphone. And as you might remember, I recently did a video at Gearfest in London, and where you guys could win this microphone. And later in this video, I'm gonna announce the winner. But now let's dive into microphone land with Christoph. First question. Transient response of a microphone. Some microphones appear to sound faster, some are slower. So what makes a microphone sound, what gives a microphone a good transient response?
Most things in microphones are combinations of acoustics and electronics. So first of all, you have the transducer itself, and then that can be from a very large dynamic transducer, like a dynamic microphone, obviously, to a very small diaphragm condenser, or even more extreme, a ribbon. So there it's really a mass thing. So the heavier the thing, the less fast it moves.
The membrane, so to say.
The membrane, or in the dynamic system also the magnet, which is attached to the membrane.
Right.
So there, more mass makes it slower, obviously.
Right.
Nevertheless, the second thing is the electronics. So you can have very slow electronics, or you can have very fast electronics. So actually you could build a dynamic microphone which is as fast as a condenser microphone if you do it basically the other way around.
Okay, and is fast always better?
That depends. I mean, if you have somebody who has a lot of transients in his voice, maybe too much, a microphone which tames that down might be a good choice. I mean, you have people using dynamic microphones for studio recordings, right? For vocals.
Right. Especially where I come from in metal. A lot of people do that because they want to have less details or less of that, like mouth clicks and all that stuff, right? But so that does not mean that dynamic mics in general are kind of slower than condensers. It depends on the membrane and the electronics.
Up to a certain limit, I would say. So at some point you cannot make it any faster because it's a moving system and it has a lot of mass. But to a certain extent, yes.
But that also means the smaller the diaphragm, the faster the system.
Right. The lighter, and this typically means the smaller, it would be faster. And the ribbon, for example, is maybe not that small because it's a long thing, but it's an even thinner, sometimes even thinner material than a condenser membrane.
Right.
So therefore it can be less in mass and faster.
Right, because I think a lot of people don't know that ribbons actually have a great transient response just because they usually sound a little darker. People don't get that, but it's like you just bring back the high frequencies and they actually are really, really fast, right?
And I mean, there are some ribbon microphones which have a lot of high frequencies. I mean, not all of them have, I don't know, 7K and then it stops, right?
Right.
You have some actually old designs also which have resonators sometimes in front, which extend almost to 20 kilohertz. And
lately there have been a lot more ribbon microphones with a more flat frequency response.
Right.
But talking about like smaller diaphragms and isn't self noise a problem of smaller diaphragms? That leads me to the next question that somebody sent. Is like there are microphones with a lot more self noise than others. Where does that come from? From the diaphragm or from the electronics or from?
Again, both.
It depends. The answer will always be it depends,
always,
right?
Same thing. So you have here it's the opposite. So if you have a larger diaphragm, you will have a more sensitive capsule. That means a higher output. And the higher the output, I mean, you know it from the microphones. If you have a less loud microphone, you need to cramp up the preamp, right? And that could bring up the noise also already of the preamp, of the electronics. So that means if you have a very large diaphragm, you can build a quite noisy electronic. And then the final noise, which we call the equivalent self-noise. So that means the self-noise as it would be in sound pressure, because of course the self-noise of a microphone is an electronic signal, but with the sensitivity of the microphone, it becomes a sound pressure level somehow, an equivalent sound pressure level. So that means you can then have a microphone which has a good self-noise, a big diaphragm, bad electronics. On the other end, you can have a very small capsule, which is very unsensitive, like a small diaphragm condenser microphone, or even the even smaller the measurement microphones, which have really tiny capsules. And then you need really good electronics.
So it's actually more difficult to design like a small diaphragm or to avoid self-noise with small diaphragm condensers, right?
So actually that's one of the weaknesses of the typical measurement microphones you find, the small ones, that they almost always have higher self-noise than ours, for example. So that's why you have to use more microphones if you do noise measurements, actually.
Okay. And that also means you have different electronics in your small diaphragm amplifiers compared to an 818 or...
Not really, because we don't take anything for granted. We always want to be the best performance, but we could, yes. So if I want to have the same self-noise with a large diaphragm than a small diaphragm, I could use less good electronics. But if you look up the numbers, our large diaphragm have better self-noise than the small condenser, simply because we use the best electronics we can build. Yeah. And with the small condenser and the lower sensitivity, it becomes a little bit more noisy.
Talking about designing microphones, one of the questions that came up the most was like, how do you voice a microphone? How do you create the sound, the tone of a microphone? And I guess the answer is, once again, it depends, and it's a combination of different components. So maybe which ones are the main components that define the sound of the microphone?
I would see it a little bit different here, because here for me, I'm a capsule designer. I mainly build our capsules and the acoustic surrounding. So my dream electronic is a pure cable. I don't want the electronics to do anything, right? So that means I would still say the main thing is the capsule and its frequency response. So that's, I think, the obvious thing. So different capsules will sound different. This is what my aim is. I try to design the frequency response of the capsule. The second thing is then not to have mechanics which mess that up. Okay. So in microphones, you always have a compromise between robustness and not affecting the sound. And this is why we have our open acoustic technology, as we call it, where we always try to have a very mechanically robust microphone with the least effect on the capsule.
That means reflections from the housing and from the grill and stuff like that. Okay.
I think you saw that. We have, for example, below the capsule, we have this diffuser foam, which tries to avoid reflections in the microphone. We always work on that principle. The OD505 you just showed has a rear entrance for the sound so that it's not blocked and stuff like that. So that's the second thing. So the mechanics around the capsule. Okay. And then obviously the third thing is the electronics.
Unfortunately for you, right? Yeah, but you can't avoid them, right?
But here I would more see it as a thing which should not mess things up. So you cannot make it better with electronics. Typically, you can make it worse, but you cannot make it. I mean, you maybe can make
technically better, maybe.
Right, because maybe you want a sound which is altered by the electronics. Right, maybe that's something you want.
And when you design a capsule, are you going for a the most neutral sound, or what is your aim there?
It depends. I mean, our CC8, the small diaphragm condenser, that aimed for a really natural flat response. The large diaphragm condensers, they typically want to have some high boost there, maybe. We try to make it not too much. We try to orient on the older
EB414.
You name it, right? Yeah. So a little bit of a high-end boost, but not too much. Yeah. So it depends really on the
Which work great,
product.
by the way. I feel like it's just the right thing to be like very versatile, but also like mix ready in a way. So it works on a lot of sources in a really good way. Talking about looking for like a not neutral tone in a way, that maybe brings us to tube microphones. Are tube microphones, that was another question coming from you, less neutral? Do they sound more compressed or saturated? I mean, back in the days, I guess tube technology was just the state-of-the-art technology there is. Maybe these days it's different. So do tube mics sound less transparent than something like this?
It depends. No, I mean, tube mics, actually when they switched from tube to transistors, the tube was on the peak of its technology development.
That was when? That was in the 60s or 70s?
It depends on the company, 60s, 60s, 70s, more the 60s, I would say. And there actually the good, this is also one thing you have to know, back in the days, in the 60s, microphones were mainly developed for broadcasting. And broadcasting was a technical thing. They didn't want coloring in any way, right? They wanted a low self-noise, mainly high SPL and natural microphone. That's what they wanted, and that's what people built for them.
So a U47 or 67 or a C12 were not designed to have a sound. They were just designed to sound
actually
neutral.
If you have time for that side story, we had the designer of the original C12 here in our house, and we did an interview with him. And this high frequency boost you have for the C12 microphone actually came because the broadcasting wanted a better self-noise. So what they had to do is they had to change the inner dimensions of the capsule, which resulted in more output, but with a slight high-end boost.
Okay.
And they...
Where does the high-end boost come from?
It's internal volumes, gaps between the membrane and the capsule, so it all works together. So it's not just one thing you tweak. Okay. And that's the C12 sound which came up by that. So actually it was I wouldn't say a happy mistake, but something like that actually, right? This is the thing. So in the 60s, 70s, it was defined by broadcasting, and the tube mics actually were hardly colored at all.
Or not intended to be colored.
Not intended. I mean, of course, if you push them, if you sing very loud, for example, then they will do something, of course.
That's what I mean, because that's my impression. Like with some tube mics, that they do color the sound more. You know, the more you push them, right?
It's a transistor. Typically, it works or it doesn't, right? So it's you know that from guitar amps also. If you crank them up, normally the saturation doesn't sound that good. Maybe depends. Of course. Some try to emulate tube sounds, but a tube is a little bit easier to deal with. I would say that the distortion which comes up is more gentle, maybe so to say,
smoothly, like
right. But on the other hand, the first transistor microphones which came out, and some companies still use these technologies and these layouts and schematics, they actually are worse, from my personal opinion, than the last tube mics in terms of how they alter the sound.
Okay, because they were like clipping suddenly or something? Or
Right. I mean, if you just look at the data sheet, so there are some microphones where they switched from tube to transistor, and just look up the numbers. They have 10 or 15 dB less max SPL because that early transistors and the layout, and I mean, people also the experience handling these electrical parts was maybe missing in that days. So there was actually a big step down in performance, so to say. And all the tube mics which are now these days, I mean, they are built to color the sound, I would say, because people expect that. Right. I would say maybe 5% of the people who talk about a U47 or C12 ever heard it. Right. I was lucky. We had all of them, and we checked them out, and actually they are not as colored as you might think. At least the not modified ones. That's the second thing. Then people try to change this and that, and
then it depends on how they aged, right? And
everything, right?
Correct. Talking about really expensive microphones, so I love this microphone and I use it a lot, and I would say it's my go-to desert island mic, as I've said many times on this channel. And this is, I think, around 1K, right? Or roughly, 1K euros. I can also get mics that will cost me 5K or 10K or 15K. So is that all voodoo, or at which point do things technically still get better? Because you also build stuff in Austria, so you're not saving by whatever building things in Far East, and do the other mics have better components, or is there, what makes them expensive?
It depends. Some mics are simply expensive because they can be expensive. Some are built in very low quantity, so that makes it more expensive. Of course, if we source 1,000 of the metal parts, it's a very different price if you source 7, right? So there's this really the boutique niche, where, I mean, pricing is done according to the market. But of course, this is, for example, it's a compact microphone, right? So you can make some things bigger, then maybe you have even space for better electronics or more components. And bigger also makes it more expensive because it's more material and so on. I would somehow say up to maybe 2.5K something is around where there's like a break point where it makes sense, right? So where you have better components, maybe better tests behind it, all that stuff. And afterwards, it's a quantity thing, I would say. I mean, if we would put out a tube mic and sell 50, then probably price needs to be very high so that we can make it right. Robustness is a thing. All the testing behind it is a thing. I mean, that's a big difference, I think, between building in Austria, where we have quality control under our shelter, and we can look after each microphone. You probably saw the amount of tests we do.
I did.
Versus we just source them from somewhere. We actually have one microphone which is built in China and uses the same capsule as in our OC-18, which is the one diaphragm version of the OC-818, where the microphone is built in China, but we have the whole quality control. We don't do the tests here, but it's our test system. We get the data, we regularly control it, and of course we do all of the time, we do some tests and sample checks. I think that's a main difference.
That was another question. about testing, because somebody asked about matched pairs. Because what's the reason that the same microphone has differs in sound? Is that just quality control? Is that the selection of the components? I think in your case you don't even offer matched pairs because you don't need to.
Right. So as we built the capsule here, and for the deviation, I would say definitely the capsule is the main thing, because the capsule is a very sensitive mechanical part.
Yeah.
Electronics hardly differ. I mean, electronic components do normally have 5% maybe deviation between them. A mechanical thing like a capsule has more. And as we build the capsules themselves, we can define the limits ourselves and say, okay, what is still a good capsule? What is not a good capsule? We do that in listening tests. So we really build like an upper limit sample and a lower limit sample and listen to it. Okay, do we hear a reasonable difference, or is this still okay? And as we have this in-house, the last thing we then do for all our studio condensers, I would say, so that means the OC-818, the OC-18 and the CC8, is we calibrate them. So that means we bring the frequency response to the same level, so that they are all at the same loudness, basically. We don't really need matched pairs anymore, because this is typically, if people buy a matched pair from another company, they typically select which ones, what makes a pair.
Yeah, right.
But as ours are so small in deviation, we don't
need that, which is great. Going back to the price of microphones, but is tube technology more expensive?
Yes, I mean, here it's not. It depends. Here it's a yes, simply because a tube itself is quite expensive. Good tubes, especially. Yeah. Noise is a big thing. So you can buy cheap tubes, but they are noisy typically. You always need a transformer. Transformer is a big mechanical part. There are very bad transformers, again, which you can get cheap. But if you want a certain quality, it's like, I don't know, maybe 10 or 15% of the whole microphone can be the price of the transformer.
Oh, wow. Okay.
Yeah.
Which again colors the sound a little bit, right? Compared to transformerless mics, or is that?
It's again a thing, if you design it right, actually, up to a certain extent, it does not color at all. So it's not like that every transformer colors the sound. It's a thing of design.
But it can.
It can,
if that's what you want. Right. Still waiting for your first tube mic then.
Yeah, a lot of people are waiting.
Now to something more technical. Let's talk about polar patterns. I think that's something that a lot of people don't really understand. How do you create or define the polar pattern of a microphone? If it's a cardioid or an Omni, how do you define what the microphone hears technically?
I mean, I have a very easy explanation, which I can demonstrate with a CKR6 capsule. So that's the one-sided capsule of the one which is in the OC-818.
So the cardioid capsule?
The cardioid capsule, right? So you see here in the backside, there's a white thing. I think you saw that probably when you looked over Jenny's shoulders building the capsules. This is the acoustic resistance. And you can very easily do two extremes. If I would block that, so if I would put my finger, which you should not do at home, put my finger here or whatever to make it sealed, this microphone would become an Omni.
Why?
Simply because there is only sound coming from the membrane, and also sound which comes from behind would walk around or drift around the membrane.
Okay.
Not for high frequencies, but everything up to 10K or so would be omnidirectional. I could do the other extreme. I could remove this mesh, and then I have sound from this side moving the membrane. I have sound from this side moving the membrane. If the sound is coming from that side, it would move equally the membrane, for example, in here. It
cancels?
And it cancels,
so
right?
It's a figure of 8.
That's a figure of 8, correct.
Okay.
And what we do now with the acoustic resistance, it's like a fader. Imagine it as a fader between Omni and figure of 8.
Yeah.
And half the way of this fader would be the cardioid.
Okay.
That's my simplest explanation.
Okay. You mechanically turn this into a cardioid by adding this backplate thing with letting in a certain amount of
sound, right?
Yeah, right.
With there's also then the phase delay, so that means the sound coming here to the front side needs more time coming to the back side, so that's getting more complicated then.
Okay, so then it also cancels out in certain frequencies, I guess?
Right.
Okay.
So this is a good thing you mentioned, certain frequencies. So the goal of me as a capsule designer is to have a very broad frequency cardioid. Because it's easy to have a cardioid at one frequency, but it's hard to have it over the whole range. And this is what typically people define as the spill sounds bad or not, right? So the off-axis sound, how does it sound? And that's a big challenge. That's, I think, the thing for designing capsule.
And then if we talk about multi-pattern microphones, you have two capsules.
Right.
And
so we have two cardioids, so one facing this side, one facing to you. And in the microphone or in post-production, I can then combine these two. The simplest examples again is figure of 8 and Omni. So if I sum the two cardioids, it would become an Omni.
Yeah.
And if I sum them with one out of phase, it would become a figure of 8.
Okay.
And then again, the balance between those two. So if I sum them half or sum them 3/4, 1/4, I get broad cardioid, hypercardioid,
all the in-betweens.
Right.
Maybe we can even demonstrate that now, because one thing that makes this microphone special, maybe you can see it, is that there are two outputs. So there's the regular XLR output here, and then there's another mini XLR on the back, and they kind of carry the signals of both the membranes on each side, right?
Correct.
So right now we have, this is in a figure of 8 mode, so you can hear him talking on that side and me talking on this side. But if I keep on talking now, we could also set this to an Omni, and then you will probably hear that it gets a little more roomy, but we can also turn off his side. So if you say something now...
Yeah, I can still say something, but you will probably not hear me as good as before because I'm talking to the rear of the cardioid.
Right, and probably I'm going to sound a little more... how do you call that? Like a little more mature with a little more sexy low end or something because of the proximity effect. So that's one really cool thing about this microphone, that you can just record both sides and determine in the post-production during the mix which pattern you want to use.
And frequency dependent. So you can do it depending on the frequency you want to do that.
That's really cool. 4 bands, I think, right? Or
up to 5 actually.
Up to 5 even. So I think I've demonstrated that in a guitar video. That was really powerful. I'm gonna put a link here, so check that out. It's really, really cool. Because obviously, next question, microphone changing the pattern also changes the sound, right? Mm-hmm. Is that because ideally it should not, maybe, but it always does a little bit, right? But that can also be used. Again, check out that guitar video. But it is the proximity effect that changes when you change the pattern, which increases the bass or not. What else changes? Why?
The main thing which changes is the high end, and this is because, as I said, the cardioid will not always be perfect for all frequencies. So depending, for example, if you have a 10K, more of a hypercardioid, then it will be a different sum frequency response than at 1K. Or if it's more broad, like already an Omni or something like that, it will also change that. So this is why the frequency response in the high end mainly changes.
Okay, yes. Got it. Now I want to switch to somebody else in this company, because we don't only have acoustic engineers, we also have electronical engineers.
Correct.
And we're going to magically switch over to Paul now, and he's going to answer some more questions. Say hello to Paul, one of the electrical engineers, right?
Yes.
Mic preamps. I think at least 4 people have asked about the importance of mic preamps. How important is the mic preamp for a microphone like this?
Usually it's an artistic decision, of course, because usually when you have a very special choice of mic preamp, it's always about the sound of the mic preamp and about the things that the mic preamp may alter on the sound. So usually you choose a different microphone preamp because you want to alter the sound and not to preserve the sound.
But how important is it? Like, how much does a mic preamp actually change the sound or alter the sound of a microphone? Would you say it's an important factor, or is it like...
I think it's an important factor from my personal experience also, as some kind of music producer myself. And for example, some microphone preamps have load impedances, which may be not so easy to drive for microphones. I think this is originated in the tube microphone era, where sometimes you used those lower impedances to squash down the higher levels of the microphones, thereby also having more distortion of the amplifying tube in the microphone,
which accidentally sounded nice or had some kind of introduced some kind of nice character.
Yes, this is something that usually with most transistor microphones it's not so nice, because usually nothing happens at first for lower signals, but the max SPL of the microphones that get degraded very much.
Okay.
Because most tube microphones are not phantom powered, so they have much more current available from the external power supplies.
Sure.
But phantom powered microphones usually have a very, very slim power budget. And we try, as electrical engineers, try
Your
the best to use almost all of it to provide max SPL, and this is something that we try to do. One of our specialities is actually to get above 145 dB. Most of our microphones can reach 150 dB SPL,
which is impressive, yeah.
Without using the pad.
Yeah, right.
So the pad usually for our microphones is just there to save the preamp. So this is the next thing, I think, that depends on the preamp. But also some preamps have front ends which introduce large capacitive loads.
What does that mean?
Yeah,
what happens if
this means that the preamp acts as if you would already have a long XLR cable.
Okay.
And this very much depends on the microphone. Some microphones may react to it in lowering the high frequencies sometimes.
Aren't like passive microphones more prone to a reaction like this? Both
Yes.
impedance and capacitor, like compared to an active mic?
Yes, of course. And also transformer coupled microphones are more susceptible to this. So all transformer-less microphones should be more or less fine when it comes to those reactive loads.
Because I remember doing a video a few months ago where I used this microphone.
Yes.
And I used a ribbon and a dynamic mic and I made different impedance tests, like different input impedances of mic preamps. And I gotta say, this microphone was very stable. So compared to dynamics and ribbons where there were massive changes, especially in the higher frequencies, this was like, it doesn't really care. You can use anything and it worked pretty well.
Yes, the only thing that will be degraded is the max SPL, of course.
I didn't try that, maybe. Maybe
yes.
I should have recorded something very loud.
Yeah.
So that's where I hear a difference. If I record whatever, something like a closed mic snare drum or something.
Yes.
And if I lower the impedance of the input impedance of the preamp,
it depends very much on the electronics because not all transformer-less transistor mics are built the same. For example, when it comes to our microphones, we don't really have any meaningful THD from the electronics, even when it's loaded by a very low impedance of the preamp. But the microphone will clip at a much lower level when it drives low impedance.
Right. Okay.
Yeah.
What is the recommended impedance for a mic like this? Input impedance of the preamp?
I think it's usually most preamps with phantom power enabled have like an impedance of 2 kilo ohms.
Yeah.
And this
Should
is
work, yeah.
Yes. And our microphones are tested for the spec with 1 kilo ohm.
Okay.
But below that, we can't guarantee anything.
Okay. Dankeschön. Thank you so much.
Anytime.
And now we will magically go back to Christoph. And here we are back with Christoph. And now I want to look into the future of the microphones. We actually had some AI related questions. And as we all know, you have a tradition, Austrian microphone building tradition, but you also have a lot of innovative features like the dual capsule with dual output and things like the plugins and things like a Bluetooth option that I haven't used where you can switch the pattern from your phone.
Yep.
But let's look into the future. Like first question would be, somebody asked if it's possible to have a microphone like see or understand the source and then automatically switch to the right polar pattern and to the right settings.
We somehow, I would say, have that with this microphone and the Polar Designer plugin. So in the Polar Designer plugin, there's the termination control, as we call it.
All right, yeah.
The
Schwarzenegger,
right? And here you can put in your DAW mark something you call the spill you don't want to have, and something you call your source material, which you want to have. And then magically the system will find the perfect polar pattern, which makes the source sounding and the spill the least, at least.
I haven't tried that.
Okay.
That actually answers my third question, because I was asking for if it's possible to have like a fingerprint, somehow like denoisers work, that you show them what you want, you show them what you don't want. That's exactly what it is.
I mean, it's a little bit different, of course, because first of all, we can only change the polar pattern in this axis, right?
Yes.
So we cannot switch to the side, for example, with this microphone. And what you can also not do, a denoiser typically puts the noise out of the same signal, right? But all these systems have latency. I think that's the big thing, which yet makes them not interesting for live situation, where that would be the best thing, I would say. The latency with everything related to machine learning is nowadays at least a problem.
Okay. What about presets? That's what somebody asked, like having different tones inside one microphone.
We have it again somehow, I would say, in this microphone, because with the Bluetooth dongle you talked about, you can not only remote control, but you can store a setting in the microphone. So that means the polar pattern, the filter, the high pass filter, and the pad can be stored. We have the last switch position, correct, which is by default. If you buy the microphone, it's a white cardioid. But if you use the dongle, and you can set whatever you want, and if we thought there's a thing for a roadie, for example, on stage who puts up the microphone for the overheads, he just has to switch to the last position, and independent of what the filter says, independent of what the pad says, it's stored, right? As you said before, as the microphone has a little bit of a different sound in Figure of 8 or Omni, this somehow already is a source thing, because it changes the sound. But yes, you could do that. The thing, of course, is that would make it a digital microphone. So until now, besides our Mic Creator USB microphone, obviously, everything we do is fully analog. So even this microphone, although it's calibrated, although you can remote control it, it's pure analog. Audio path is pure analog. And as soon as you do it with presets, you go into the digital domain.
Right. Then again, introduces a certain latency. Probably.
Latency, maybe sound change, because you go into digital, then nevertheless, typically you want to have your analog output. So that means you have one conversion, analog to digital, digital to analog. But it would be possible.
It's less pure. Let's say that. It's less pure.
Yes, maybe.
But whatever works. I'm really curious what you guys will come up with in the future, right? Maybe a tube mic, maybe something else.
Which could be the opposite from the preset DSP microphone.
Yeah, but isn't that cool? Like that's what I said. It's like there's a certain tradition that makes sense.
Right. And this is a big advantage of our company. We can basically do whatever we want, because we are not bound to we have the knowledge, the experience knowledge, but we don't have the history where we need to do that and that.
Exactly. Yeah. And I'm really excited. I got to say, I mean, I've been using their microphones for a while now, and I really love them. But now, having been here and having met the people, a lot of heavy metal people, by the way. So really nice company. I had a lot of fun. Thank you so much, Christoph.
Welcome.
Now it's time to announce the winner of the lovely Austrian Audio OD505 active dynamic vocal handheld microphone. I just looked it up on Sweetwater. It's a $300 value. Not bad, right? And I'm pretty sure it's not only a great handheld stage mic, I'm pretty sure it's great for vocals in the studio as well, especially harsh vocals. Try it on a guitar cab, try it on drums, have fun with it. And this time I actually don't know where the microphone is going. I know it's going to a guy called Sam. So I'm assuming you're in the US. Anyway, his family name, I don't know how to pronounce it, is sounds French. So the French would say paquette. But I'm sure if you're American, you say paquette or paquetti or something like this. So congrats, Sam. This mic is yours. Because Sam also left a comment under the Gear Fest video saying, Austrian audio mics do look nice. There's a few models I have my eye on. So now there's one model less for you to have your eye on, because this one is coming your way. Please get in touch, or I'll get in touch as well. We'll find each other, right? And maybe, Sam, also please leave a comment under this video letting me know how to pronounce your family name, if it's Paquette or Paquetti or Paquette or how you pronounce it. Maybe you are not even from the US and I'm totally wrong. Maybe you are French, or I don't know. So that would be a nice surprise. All right, that's all for today. Let me just say thank you one more time to Austrian Audio. I had so much fun there. There's another video coming up because we filmed the entire process of how they built the OC-818 microphone, and I try to capture this like in a very idiot-proof way so people like you and me actually understand how a microphone is being built. And one thing I love about Austrian Audio is that it really feels like family there. Everybody's super passionate about microphones. It's not a big company. Everybody is really cool, and now they just know why they're working there. I mean, a lot of ex-AKG people who refused to go to China, you know, so they wanted to stay in Vienna. And it's maybe the same thing like when I visited AEA microphones in Pasadena. I had like the same feelings. I really like to support these companies who not only build great gear, but also like have the right mindset and are very passionate about what they do. Some of you might remember that we had another giveaway in the GearFest video, and that was an Audient USB interface. There will be another video very soon because right after I visited Gearfest in London, I visited Audient. They invited me to their immersive studio to do my very first Atmos mix, and I filmed the whole thing. So when we release that video, I will announce the winner of the interface. So another reason to stay tuned. If you haven't subscribed to this channel, now's the time to do it, and ring the bell, ding, dong. That's all for today. I see you in hell, motherfuckers. I see you in hell, my friends. Bye bye, auf Wiedersehen, servus und adieu. Ciao.